Hey guys, what's up? I'm going to look at electron volts. Electron volts are a very small unit of energy, and it's particularly useful when we're looking at particles because they only have very small quantities of energy compared to macroscopic objects that we have in our everyday lives. So we use it when joules just aren't appropriate. It's not an SI unit though, so you have to be careful that whenever you do calculations, we always use joules. But electron volts can be very useful and they're much more manageable as a unit. So what's the definition of an electron volt? It's the energy gained by an electron when it's accelerated by a potential difference of 1 volt. This diagram shows what's going on here. We've got a 1 volt EMF, which is connected to two parallel plates. We have a negative one and a positive one. The positive one is the one connected to the positive terminal of our EMF supply. In between there, we've just got a single electron. Let's just imagine this situation. And you should know that electrons have a negative charge. They have the elementary charge, which is minus 1.6 times 10 to the minus 19 coulombs. This electron is going to feel an electric force because it's attracted towards the positive charge of the positive plate. And whenever you have a force, you get an acceleration. Therefore, this electron is going to accelerate, it's going to gain speed, it's going to gain in velocity. And because it's gaining in speed, it's going to gain kinetic energy. So this electron is accelerated by this potential difference across these parallel plates, and it gains kinetic energy. How much it gains is given by the formula W for energy is equal to the charge multiplied by the potential difference. So we can say how much energy this would gain when accelerated by 1 volt. The energy gained would be equal to 1.6 times 10 to the minus 19. I'm just ignoring the negative here. Multiplied by 1 because that's our potential difference. So the energy this electron will gain is simply 1.6 times 10 to the minus 19 joules when an electron is accelerated by 1 volt potential difference. We define this amount of energy to be equal to 1 electron volt because we're accelerating 1 electron by 1 volt. And this means that we've got a much more sensible unit to use for particle physics. Let's have a look though, if we used a different accelerating potential difference. So if we have 10 volts, we're simply going to have an electron gaining 10 electron volts, I should say, of kinetic energy. If you use 200 volts, you get 200 electron volts of kinetic energy. Similarly, if you have 250 kilovolts, you're going to get 250 kilo electron volts of kinetic energy by the time this electron reaches this positive plate. If you have 50 volts, you're similarly going to get 50 EV. However, in this case, we've got 3 electrons. So each one will gain 50 EV. Therefore, in total, the total amount of energy transferred in this situation is going to be 150 electron volts. That's the combined energy in this situation. So we use electron volts when we're dealing with very small amounts of energy. And the definition of an electron volt, 1 EV, is 1.6 times 10 to the minus 19 joules. That's the quantity, what 1 EV is equal to. If you want to convert from a joule to EV, you have to divide by 1.6 times 10 to the minus 19. If you want to convert from EV to joules, you have to multiply by 1.6 times 10 to the minus 19. So let's just look at 4 quick examples. So I've got 50 joules here. So if I want to convert that to EV, I do 50 divided by 1.6 times 10 to the minus 19. And that gives me 3.13 times 10 to the 20 EV. So 50 joules of energy is a small amount of energy in everyday life, but it's a huge amount of electron volts. If I've got 1.2 millijoules, we've got to remember our prefixes. So that's 1.2 times 10 to the minus 3 divided by 1.6 times 10 to the minus 19. And that gives me 7.5 times 10 to the 15 EV. If we have 500 EV and I want to convert that to joules, I do 500 multiplied by 1.6 times 10 to the minus 19. And that gives me a value of 8 times 10 to the minus 17 joules. So a large number of EV is just a small amount of energy when measured in joules. If I've got 125 giga electron volts and I want to convert that to joules, I do 125 times 10 to the 9 because it's giga, multiplied by 1.6 times 10 to the minus 19, and that gives me 2 times 10 to the minus 8 joules. So that's a huge number of electron volts, but still a very small amount of energy when measured in joules. Based upon the definition of an electron volt, the energy gained when an electron is accelerated by a potential difference of 1 volt, we can use that to calculate the final speed of this electron when it's accelerated across a potential difference. So in this situation, we've got a 500 volt potential difference and we've got an electron being accelerated by it. The question says, calculate the final speed of the electron as it reaches the positive plate. And we're given this little bit of information that the mass of an electron is 9.11 times 10 to the minus 31 kilograms. We know that this electron is going to gain 500 electron volts of energy. And the form of energy it's going to be is kinetic energy, which is half mv squared. Therefore, we can calculate the velocity because we know the mass and we've got the energy. But we never ever use electron volts when we do calculations, so we need to convert this. So we do 500 multiplied by 1.6 times 10 to the minus 19 to get our energy into joules. And that gives us 8 times 10 to the minus 17 joules. If I want to now work at the speed, I need to rearrange this equation, and I get v squared is equal to 2 times the energy divided by the mass. And now I can substitute in my energy into here. So I get v squared is 2 times 8 times 10 to the minus 17 divided by the mass, which is 9.11 times 10 to the minus 31, which gives me v squared is equal to 1.76 times 10 to the minus 14. And when I square root that, I get v is 1.33 times 10 to the 7 meters per second. So this electron is now traveling incredibly quickly when it's accelerated by 500 volts. We just used two equations here. Well, we used W equals QV, or we just understood that 500 volts means the electron gains 500 EV, and we used the kinetic energy equation, half mv squared. The final thing to consider is proportionality. Let's just look at the generalized situation. If we have an accelerating potential difference of V and we have a single electron, we know that the energy gained is W is equal to QV, and the form of that energy is half mv squared. It's kinetic energy. By equating these two, we can see that half mv squared is equal to QV. The little v here stands for velocity. The large V stands for the potential difference. Therefore, we can look at these two versions of the proportionality. We can say the velocity squared is proportional to the potential difference, or the velocity is proportional to the square root of the potential difference. So in summary, an electron volt is the energy gained by an electron when it's accelerated by a potential difference of 1 volt. And 1 EV is equal to 1.6 times 10 to the minus 19. And you use that to convert between joules and EV, or from EV to joules. That's it. Thanks for listening. See you all soon.